Okay, we are going to learn about inequalities. Our inequalities are our less than or equal to, our greater than or equal to symbols. So those are inequalities. When I see these two examples, I see that this pointed end is facing the x, so I know that this means less than. And I know this is less than. Oops, sorry about that. Or equal to. So this one I would read x is less than. This one I would say x is less than or equal to. So if you ever see the pointed end facing the x, that means less than. Now, it could also look like this. As long as that pointed end is facing the x, I read that x is less than. I always start by starting with the variable. X is less than. So if you ever see the pointed end facing the variable, then it's less than. X is less than. Okay. When something is less than, we are going to shade to the left. So on this one, we will also shade to the left. And then there's another thing that we need to know. If there's an equals under the symbol, we will have a solid circle. And if we don't have an equals, we will have an open circle. Okay, here I have the big mouth facing the x. The big mouth facing the x. If the big mouth is facing the x, we say greater than. And this one would be greater than or equal to. Now, it doesn't have to look like that. It could look like this. The big mouth could be facing the x with the x on the right-hand side. So if I ever see it looking like this, I start by reading the x first, and I say x is greater than. Okay, so we just have a few things to get in our heads. If the pointed end is facing the x, the pointed end is facing the x, that's less than. If the big mouth is facing the x, the big mouth is facing the x, that's greater than. When it's greater than, we shade to the right. And like I said a minute ago, if there's an equals, we're going to have a solid circle. And if there's no equals, we will have an open circle. Okay, single variable inequalities graph on a number line, which is what we're going to practice doing today, graphing on a number line. So let's look at these following examples. So I always ask myself, is the pointed end facing the x or is the big mouth facing the x? If the pointed end is facing the x, then this is less than. And I always start with the variable first. X is less than or equal to 10. So I'm just going to put a 10 on my number line. Would it get an open or a closed circle? It's going to get a closed circle, a solid circle. And where are our numbers less? To the left. Less than left, less than left. Now, this could have looked like this. x is less than or equal to 10. These two statements are exactly the same. Do you see how the pointed end's facing the x? The pointed end's facing the x. If the pointed end faces the x, we read it the same. X is less than or equal to 10. X is less than or equal to 10. So you just have to pay attention to what's facing the x. Okay, on this one, what's facing the x? Is it the pointed end or is it the big mouth? It's the big mouth facing the x. So I'm going to read this one using the words greater than. And I always start by reading with the variable first. X is greater than 200. So I'm going to put 200 on my number line. Would I have an open circle or a solid circle? An open circle. And where are our numbers greater? Greater is always to the right. So less than left, greater than right. Okay. I am getting rid of this middle section here. Okay, now we're just going to solve some equations. So I only see one x in the equation, so I'm going to circle everything smushed with it. Whatever's outside the circle, I add or subtract. So I'm going to subtract 6 from both sides. The 5x drops, the symbol drops. These two negatives add to be a negative 10. Then I undo my multiplication with dividing, so I divide both sides by 5. And then my symbol drops, and negative 10 divided by 5 makes negative 2. Now there is a certain rule here that you guys will need to know, but I'm not sure if we get it into it in this lesson. But I'm going to tell you about it right now. If I ever divide by a negative number or multiply by a negative number to both sides, I will flip around this inequality sign so it would be facing this way. But because I divided by a positive number, then there's no flipping. The symbol just stays the same the whole way through. So if we come to a problem where I have to divide by a negative, this sign right here will flip around. And I'll show you what I mean after a little bit. Okay, so this is my answer. And is the pointed end facing the x or the big mouth? The pointed end is facing the x, so I read this with less than. So I say x is less than negative 2. Would I put an open circle or a solid circle? An open circle. And which way is less? Less than left, less than left. So this means every single number that's smaller than negative 2 is an answer to this problem. That's the thing about inequalities. When you solve them, you don't just get one answer, you get infinitely many answers. Every single number you can think of that's smaller than negative 2 is an answer to this problem. Okay, let's look at number 4. So first I'm going to circle everything smushed with my x, which is just the x. Whatever's outside the circle I add or subtract. So I'm going to subtract 16 from both sides. The x drops, the symbol drops, and 7 minus 16 is negative 9. I never divided by a negative, I never multiplied by a negative, so the sign didn't flip around. Okay, I look at what's facing the x. Is the pointed end facing the x or the big mouth? The big mouth is facing the x. So I'm going to read this with a greater than. So I say x is greater than or equal to negative 9. So I'm going to put negative 9 on my number line. Would I use an open circle or a solid circle? A solid because of the equals underneath. And greater than is which way? Greater than right. So it's all about what's facing your variable. If the big mouth faces it, greater than. If the pointed end faces it, less than. Okay, let's flip. Okay, here we have to translate, and then we're going to solve, and then we're going to graph. So 7 is less than 3 less than 2 times a number. We see 2 different less thans in there, and these 2 less thans mean something different. So when I read that 7 is less than, that is this. 7 is less than. When I read this back part, 3 less than 2 times a number, do you see a switch word in there? Less than is our switch word, so I start with the back of the sentence. How can I write 2 times a number, to x, to n, to whatever letter you want? Less than means minus, and then I come back to the 3. So this is 7 is less than 3 less than 2 times a number. It seems confusing, but because this lesson is about inequalities, less thans, greater thans, less thans or equals, greater than or equals, then that's kind of a hint as to why this was a less than symbol. And then this is like what we've been looking at for weeks now. Okay, I circle everything smushed with my x. Whatever's outside my circle, I add or subtract. So I'm going to add 3 to both sides. The 2x drops, the symbol drops. 7 plus 3 makes 10. I undo multiplication with division. I'm dividing by a positive, so my sign's going to stay the same. And 10 divided by 2 makes 5. Okay, I look at what's facing the x. Is the pointed end facing the x, or is the big mouth facing the x? The big mouth. So I'm going to read this with a greater than. So this is x is greater than 5. So I put 5 on my number line. Would it be an open circle or a solid? Open. And which way is greater? To the right. So every number that's bigger than 5 is an answer to this problem. When you have the equals and it's a solid circle, then that means 5 and everything bigger is an answer. Whereas here, since I don't have a solid circle, that means 5 is not an answer. It's just every number bigger than 5. Okay, next one. 11 more than a number divided by 5 is at most 18. This part that says is at most 18, that's going to be where our inequality symbol comes in. So let's read the first part of this. 11 more than a number. Do you see a switch word there? Yep, more than. So let's start with the back. How can I write a number? X, more than, plus 11. So this is 11 more than a number, and then it's divided by 5. So divided by 5 is at most 18. What does it mean to be at most 18? Smaller than 18, bigger than 18, equal to 18, is at most 18. If I say something is at most 18, that means it's exactly 18 or less than 18. Okay, now I need to solve this problem. This problem would be really easy if I didn't have that divide by 5. So let's get rid of our divide by 5. How do you get rid of division? We multiply. So I'm going to multiply this side by 5, and I'm going to multiply this side by 5. Over here, these 5s are going to cancel out. All I'm left with is x plus 11. I drop my symbol. And 18 times 5 makes 90. And then I just get rid of my positive 11 by subtracting. And then my symbol drops. And if I subtract that, I get 79. Okay, is my pointed end facing my variable, or is my big mouth? My pointed end is facing it, so this is less than. And less than is to the left. So I'm going to put 79 on my number line. Open circle or solid? Solid circle because of the equals. And less than is to the left. Less than left, less than left. So 79 is an answer to this problem, and every number smaller than 79 is an answer. Okay. Gary weighs 170 pounds. He is loading a freight elevator with identical 65-pound boxes. The elevator can carry no more than 2,000 pounds. If Gary rides up with the boxes, how many boxes can be loaded on the elevator? Okay, so Gary weighs 170 pounds. That's just a single weight. There's no variable behind it because it's not 170 per anything. It's just a flat 170 pounds. Plus, he is carrying up identical 65-pound boxes. And I'm trying to figure out how many boxes he can take with him. So if each box is 65 pounds, then it's 65 times X, because every box is 65 pounds. So Gary weighs 170, plus every box he takes up is 65 pounds. And then you can't put on any more than 2,000 pounds. So the elevator can carry no more than 2,000 pounds. What does that mean? No more than 2,000 pounds. Can it hold 2,000 pounds exactly? Yeah. It can be exactly 2,000 pounds. Can it be more than 2,000? Nope. It has to be less than. Okay. I'm going to circle everything smushed with my X. Whatever's outside the circle, I'm going to add or subtract. So I'm going to get rid of my 170 by subtracting it on both sides. The 65X is going to drop. The symbol is going to drop. And then I want to take 2,000 minus 170, and that makes 1,830. And then I get rid of multiplication by dividing. So I'm going to divide both sides by 65. Since I'm dividing by a positive number, my sign does not flip. It just stays the same. And when I divide that, I get 28.1538, blah, 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 blah. There's some other answers there. So when it says, if Gary rides up with the boxes, how many boxes can be loaded? This is saying that the number of boxes has to be less than or equal to 28.1538. Okay, well, I can't have that many boxes, so I have to think about what makes sense. So what is the next number of boxes that would be less than or equal to this number? 28. He can carry 28 boxes up. So Gary can take 28 boxes with him on the elevator, because it has to be less than or equal to 28.15, and so 28 boxes would be less than that. And that's our answer. Okay, thank you. Smiley face.